This is the Waves homework booklet, question 27. Here we have a fairly standard diffraction grating question where monochromatic light approaches the grating at right angles as shown. This is the meaning of the term normally in the question. We have been given the wavelength of the light and also the grating spacing. The grating spacing corresponds to the lowercase letter d in the diffraction grating equation, and we have sometimes called it the line spacing. We're asked to calculate the angle of diffraction for the second order beam. So, using the diffraction grating equation, we can rearrange it to give an expression for the diffraction angle. Careful substitution, keeping a close eye on the units, leads us to a value for sine theta, and we can then solve to find the angle itself. Notice I've given the answer to 3 significant figures. That is because the values for lambda and d were also to 3 significant figures, and 2 is a number that we're sure of. Next, we're asked to show that no beams higher than the second order can be observed. Rearranging the diffraction grating equation, we can say n equals d sine theta divided by lambda. We want to find the maximum n possible. D and lambda are fixed, so the maximum n will correspond to a maximum value for sine theta. Sine theta cannot exceed 1. Putting that into the equation, we have n max equals d divided by lambda. This leads us to an answer of 2.83. However, n is a number and it is an integer, and if we were to exceed 2.83, it would force sine theta in this equation to be greater than 1, which is not possible. So we just need to make that statement at the end as our conclusion. The last part of the question changes the wavelength of light, and once again we're looking at a second order beam and we're told the angle of diffraction. So this time we are rearranging the standard equation to find an expression for lambda. Once again, careful substitution leads to the final answer, and again it's appropriate to give 3 significant figures, since the angle was given to 3 significant figures, and so was this value of 1.67 times 10 to the minus 6.